Hello and welcome to my YouTube channel. In this series we are going to discuss about a very important IC in electronics which is known as operational amplifiers, or in short form we call it op-amp. So in this video I am going to talk about a very simple basics of the op-amp. So let's start the video. In this video we are going to cover about op-amps. So first of all I will give you a brief introduction about the op-amps. Then I will discuss the pin diagram of operational amplifier IC 741, and then I will discuss about the ideal operational amplifier parameters. So let us start the lecture. First of all, operational amplifier is made up of two words, operational and amplifier. The word operational means mathematical operations. So using these ICs we can design almost all kind of mathematical solutions, like we can design adders, subtractors, multipliers, dividers, integrators, logarithmic circuits and differentiators. Of course we can design many more complex circuits using operational amplifiers. So therefore the word operational stands for mathematical operations. Apart from that, amplifier can be of three types. Especially when we are talking about electronics, amplifiers can be of voltage amplifier types, current amplifier types, or power amplifier types. Basically, operational amplifiers are voltage amplifiers. So remember, when we are designing any circuit using operational amplifier, most of the time we will be generating a gain in terms of voltage. So it is mostly designed for voltage amplifications. So in short, we can say operational amplifier is an electronic device which can generate very high voltage gain. Keep in mind, very high voltage gain with a differential input. We will come to this term, differential input, and generally single-ended output. So remember, differential input and output is single-ended. Let us go deeper into this term. First of all, let us go through the pin diagram. Pin number 1, when we discuss about the pin diagram, pin number 1 starts from here and pin number 8 is here. So pin number 1, 2, 3, 4, and then 5 starts from here, then 6, 7 and 8. So pin number 1 and 5 are used together for offset null operation. We will come to this term in later videos. So pin number 1 and 5 are used together for offset null. Pin number 2 is known as inverting input. So we will be providing input from pin number 2, but it is known as inverting input. Pin number 3 is another input and we call it non-inverting input. So the term differential input is actually generated from here. So differential means the op-amp takes the difference of the two inputs and then generates an output. Therefore it is differential input. So there are two inputs in op-amp. Pin number 4 is negative supply voltage. Okay. So we provide the supply voltage from pin number 4 and that should be negative voltage. Pin number 6 is our output voltage. So the amplified output will be received at pin number 6. Pin number 7 is used to provide the supply voltage and that supply voltage should be positive. So pin number 4 and 7 are supply voltages. 4 is negative, pin number 7 is positive. Pin number 8 is left unconnected, or we call it not connected to any particular pin or voltage. So this is how the pin diagram of op-amp looks like. There are many types of op-amps, but I am talking about IC741, which is very common in electronics world. So what are the different ideal operational amplifiers parameters? So ideal operational amplifiers voltage gain should be infinity. That means when we say voltage gain, it is generally written like this: V output upon V input. So when we say the gain is infinity, then that means even when you provide zero input voltage, you can get almost infinite output voltage. This is ideal value, and this is not accepted or not achieved in practical life. So theoretically, the open loop gain of op-amp is infinity. The input impedance, also known as input resistance, although they are two different terms, impedance and resistance are not the same, but still input resistance is infinite. That means no current is consumed by the op-amp. So no current moves into the input terminals or moves into the IC. Second, output resistance is 0 ohms. These are ideal parameters. The bandwidth, that means the frequencies for which the amplifier can generate amplified output, is infinity. So it can work for any frequency range ideally. That means from 1 Hz to infinite Hz. So amplifier can generate amplification for almost all frequency signals. So this is ideal parameter. Offset voltage should be 0. We will come to this term, why offset voltage is important and what does that mean. Ideally it should be 0. Remember, practically all these above mentioned parameters are not achieved or are not achievable in real life. So in short, this is the diagram of op-amp, where we can see there are two inputs, V positive and V negative. So pin number 2 is V negative, that is inverting input. Pin number 3 is positive voltage input. So pin number 3 is V positive. R in is input resistance. So it is infinite in case of ideal op-amp. So that means no current will flow towards the op-amp via pin number 2 or pin number 3. So I will be 0 here in this direction and I will be 0 in this direction. Pin number 7 is V positive supply. Pin number 4 is V or voltage negative supply. R output is the output resistance. So basically it should be 0 ideally. Okay. Now coming to this particular block, this is a voltage source, or we can say dependent voltage source, and here G is the gain multiplied by V input. So G is infinite in terms of ideal op-amps. So gain should be infinite multiplied by V input. V input is nothing but the difference between the two inputs, V positive minus V negative, and V out is our pin number 6. Mathematically, operational amplifiers equation is very simple. The equation is V output here is equal to A, which is nothing but gain, open loop gain, times the difference between the voltage at pin number 3 and pin number 2. And we can say it is the difference between non-inverting input voltage minus inverting input voltage. So what are the advantages of ideal op-amp? Like I said, it has got infinite open loop gain. You can read these lines, but for your kind information, these lines does not make that big statements. Remember, infinite open loop gain, infinite input resistance, 0 output resistance, and infinite bandwidth. Again, let me reiterate that these are ideal values, and there is a huge difference between the practical and ideal values for any operational amplifier. So let us briefly see how can we check these parameters. So first of all, here in this circuit, I am trying to show the offset voltage which is generated by the operational amplifier. You don't have to worry about the circuits. In later videos, we will be going more deeper to understand how to design circuits, how to generate different mathematical operations using op-amp. So here pin number 3, which is non-inverting input, is grounded. Inverting input is connected to pin number 6. This is called buffer. That means this particular amplifier is unity gain amplifier. So by the virtue of virtual ground, pin number 3's voltage and pin number 2's voltage should be equal. Or we can say pin number 2 always gets the voltage which is present at pin number 3. So pin number 3 is grounded. So here pin number 2 is also grounded. So the output that we should expect at pin number 6 should be 0. But if we simulate it, we can see the output is not 0. Rather, it is still having a small offset voltage of 1.03 millivolt. We can neglect it, but in general, if you don't want to neglect it, you can connect a potentiometer between pin number 1 and 5, and the middle terminal of the potentiometer can be connected to negative terminal of the op-amp and tune it to make it 0 volt. And by that we can make it offset null 0. Now let us check about open loop gain. What do you mean by open loop gain? Basically, open loop gain means when there is no feedback. Feedback means here you can see the output pin number 6 is connected to the input pin number 2. So this is called feedback, providing output to the input. So this is feeding back the input power. Now coming to the open loop gain. Open loop means there is no feedback. You can see here pin number 2 and pin number 6 is not connected by any means. Similarly, pin number 3 and pin number 6 is not connected by any means. So I am here providing a very small voltage which is of 10 millivolt peak to the inverting terminal of op-amp. So it is a sine wave, 100 Hz, 10 millivolt connected to pin number 2. Pin number 3 is grounded. So this is basically inverting amplifier, but open loop. So there is no feedback, so there is no loop. And I am connecting pin number 6 with channel A and pin number 2 with channel B, which is demonstrated or depicted in red color. Let me simulate this. So here you can see, even with a very small voltage, we can see that the output is getting saturated. So the amplifier is getting saturated to plus 12 and minus 12. Why? Because the supply voltage VEE at VCC is plus 12 and minus 12. You can see from here VCC is plus 15, and VEE is minus 15. So that's why you can see here the output is almost saturated to 15 and minus 15. Okay. Whereas the input is a very small value which is of 10 millivolt. So 10 millivolt signal is saturating the amplifier to plus and minus 15. So it is having a huge gain. That's why the amplifier is saturated. So is this an ideal amplifier? Yes, this is almost like an ideal amplifier's behavior, but is it generating a good amplification? No, this is not faithful amplification, because we are providing input sine wave and we are getting output square wave. So the function of the amplifier has changed. So later in coming videos we will see how to design amplifiers which can provide us genuine outputs using any op-amp, and how can we generate different mathematical functions using operational amplifiers. So stay tuned in this playlist. I'll be coming up with very different kind of videos by which you can learn how to design your own circuits, and with which you can easily mathematically solve any kind of operational amplifier related circuits. If you have not subscribed the channel, then I would request you to please subscribe the channel, and thank you for watching this video.